I'm not originally from Okinawa. I only like karate from there. So my name is Minko, as Skip mentioned, and I'm working in the Angular team. Today, I would want to give you an overview of how I see the future of the front-end frameworks. Since we don't have much time, we're going to focus only on most time. We're going to discuss rehydration and serving. How many of you are familiar with the process of rehydration? I don't mean drinking water here, into the context of front-end frameworks. Rehydration? Anyone? Okay, cool. We're going to discuss particularly progressive rehydration so that we can speed up the initial load time of our applications. As a disclaimer, in this presentation, I'm not reflecting what the future roadmap of Angular is, although I'm working in the Angular team. This is particularly my opinion, and it is based primarily on observations that I have on how people have built applications over the years. So I've been talking to a lot of developers, a lot of large and small companies, and I see some common patterns. But in general, I'm really not sure how things are going to evolve in the future, right? So in the next 20 minutes, I'll be primarily just making sound. All right, so I'm not stating that the future framework is Angular or React. It might be something completely different. But in the same time, I can see how much effort we're putting in the Angular team to make sure that we're aligned with the evolving requirements of web and being part of the standardization of some of the features recently. I'm also not saying that the language of the future is JavaScript even. So in this presentation, you're not going to see any code snippets. Basically, the presentation today is going to be focused on two things. According to my observations over the years, whether a technology is going to be successful or not primarily depends on whether it makes users happy and developers happy, in this order. Over the years, there are so many examples of technologies which are not performant or not cost efficient or even not safe in type systems context, and they're still getting very popular and very widely used. So making users happy and having good ergonomics is what primarily drives adoptions. Let us look at how we can make our users happy. We're going to discuss rehydration particularly here. Let us look at how we are serving a web application, a single-page web application in 2019. We have a browser, Node.js environment, in which we can perform a server-side rendering, and also some API server that we're going to talk to in order to extract some data. First, the browser is sending obviously request to the Node.js server. This could be wrapped in another technology, of course, if we're using ASP.NET or, let's say, Go or another backend technology. From here, the Node.js server is going to start running our application. It is going to delegate a couple of calls to the API server so we can extract data. And after that, it is going to return just a string, just the server-side rendered content. And that's it. Now, the interesting things are happening in the browser. Once we receive this string, we can perform two different operations. We are first going to send a request over a network to a CDN to get our application, which could be, it is basically a bunch of scripts, and our application can go into different ways. It can even completely swipe out the structure that we got from the server-side rendering. So once we get the string from the server-side rendering, we're going to deserialize this. We're going to build our DOM tree, and from here, once the framework takes over, it can completely remove that and rebuild it from scratch, or it can iterate on top of it and perform rehydration. So that's the process of rehydration. We're just traversing this tree node by node and figuring out which are the individual nodes associated with the components of our application. In the process, we're rehydrating not only this component structure, we're also adding event listeners and eventually rehydrating state associated with these components. By rehydration in general, I mean taking the rehydration of states. I mean taking the serialized state and deserializing it so it's now part of our component instances. It doesn't matter which approach of these two we take. In all cases, there's going to be an unpleasant experience for our users for a certain amount of time. We're going to render the application on the server. We're going to deliver the rendered content to the browser is going to deserialize it into the DOM structure, and from there, the browser needs to download a bunch of scripts So these scripts can vary in size. They could be from a couple of kilobytes to a couple of megabytes. And until we completely load them and they take over the user's application, the users need to be in an uncanny valley. They will not know what's happening because the application will not be responsive at all. So this approach obviously has its benefits as well. Server-side rendering is good because social media website can take, let's say, thumbs for our web app and some description. It is also SEO friendly. Once the application is loaded, the user also gets immediate experience because we have loaded all the scripts associated with the current page. So from there on, the interaction with the web app is going to be very smooth. And the resources are downloaded progressively over time, only for the pages and the functionalities that we need. We're going to download them only once and keep them in the browser cache or in memory. But there are quite a few cons. So building stateful applications, single-page applications in general, is not easy. We need to manage very complex, mutable states. We need to make sure that changes in the state are propagated across our application. So that's not an easy thing. I bet most of you have been already using NGRX or Redux or another state management alternative, which introduces complexity in our day-to-day life. Our applications are not also optimized for server-side rendering. If you think about it, they're just front-end frameworks, primarily built for developing user interface, and we have just somehow adopted some kind of server-side rendering approach. We are going to the same set of lifecycle hooks, which are intended particularly for rendering on the client and not intended for server-side rendering. We can never be as efficient as a server-side rendering solution written in C++ or Java or even PHP. Our application is also unresponsive from this moment once we render our application. Of course, when we load the scripts and the browser visualizes the app, and until we load the actual app from the CDN and the framework takes over. So that's not ideal. Let us look back at 2008, when we were doing server-side rendering by default. That was pretty much what each web application was doing back then. In 2008, Steve Jobs introduced the best iPhone ever, iPhone 3G, and this happened somewhere in San Francisco. Around that time, I was much closer to here. I was back in Bulgaria on one competition in web development, pretty much. So that's me there with my website that I was presenting in front of the audience, like in front of this single person. I developed this single page. Oh, it's a multi-page app. I developed this CMS system about which allowed me to build web applications simpler. And one particular web app I built was for a local mountain that we had that I was very excited about. So this web app was fine for high school students, but there was something which was driving me crazy, and it still is. Do you remember the rounded corners? We didn't have border radius back then. So it's still, when I look at the screenshots, that my OCD is just driving me absolutely crazy. Anyway, I built a web app with the LAMP stack, with Linux, Apache, and MySQL with PHP. The loading experience, the loading sequence of steps was as follows here. We had our browser, which directly talks to the Apache server, which runs a bunch of PHP scripts, taking data from MySQL database, and after that, we were getting server-side rendered application by default. That was it. Later on, if we want to incrementally load some state, we were sending requests to our Apache server. Some PHP scripts were taking data from the database and returning them in whatever format we want. And we had state serialization, which was very simple. We just had to print a bunch of JSON in a script tag, and we were able to use states that we were using on the server directly in JavaScript without having to duplicate any requests. This approach has its pros, of course. It's very simple. It has server-side rendering. The application is interactive immediately because we have multi-page experience, so we just have hyperlinks. We don't need to download a router, front-end router that's going to take over the app. The application rehydrates without destroying the user interface, so we have the rehydration experience that we already described, and we're getting the assets that we need for a particular page. we rarely need Source Map Explorer as well because we don't have that much JavaScript as well. But it's not ideal. We need to, when we navigate across different applications, our navigation experience is slow, and unfortunately, we may need to process the same set of assets multiple times. Imagine we're navigating across multiple pages, they're referencing the same set of scripts. We need to download them multiple times or get them from the cache, and after that, the browser needs to go through the same process of parsing and execution for each individual script that it parsed on the previous navigation. So why are we not using the current, why are we not using this server-side rendering by default approach now? Why did we go to all this complexity of single-page apps? Well, we asked the business, and the business said that they want the power of desktop applications and the convenience of web apps, so we decided to go with single-page apps with server-side rendering. Now, let us look into the future and see how we can take the best from both two worlds, how we can have instant interactions without this uncanny valley with server-side rendering, and keep our users happy with fast navigations. What we want to do is have fast applications that are very responsive, so we want them to load fast, and we want the navigation to be instantaneous as well. Here we're going to start talking about progressive refiguration. Progressive refiguration is something that is going to help us make our initial load time much faster, and it is going to keep the fast navigation experience that we have in the current single-page applications. With progressive refiguration, we can have the same server-side rendering that we do have today. We're going to send a request to our Node.js server, we're going to fetch some data, after that we're going to render the application and just provide the the HTML associated with our app, without downloading any scripts at this time. If we have fetched some data from the API servers, we can provide them as inline JSON as well. But remember, we're not loading any scripts at this point. We'll start loading scripts once the user starts interacting with the app. So here's an app of the future, right? We have a weather widget, we have a form for editing a user profile, where we can edit, let's say, a username. We have the user avatar and some user details in the green box here on the right. This is just server-side rendered content without any JavaScript yet. We can represent the following application with a component tree like the one here. We have the app, weather component, forms controller, forms component, a profile component, icon, temperature, and so on and so forth. Now, let us suppose that the user wants to edit only the username, only their username. So they're going to update the username fields, and they're going to click on the submit button. From here, we only need to load the forms controller. So we're going to load the script associated with the form, and that's it. The form is going to send a request over the network to update the username. Once we get the response, we're going to pass the new data down the component tree, and we'll have to update the username as well. In the process, we'll have to refigurate individual components, not the entire application. So we're going to download the app component, the profile component, as well as the user details component. But everything else will still stay on the server. We just don't need the scripts. The rules of the progressive refiguration are as follows. First, we download a component only when the user interacts with it, with the DOM associated with this component, and we bootstrap a component when we pass some data to it. So it's or actually. Either when the user interacts with certain components, or when we pass new data to it. So that's when we download the component over the network and progressively refigurate it. Also, each individual logical unit has its own bundle. This means that we don't need to perform bundling as part of our build process. This is something that should happen somewhere else. Now let's go back to our example and trace the loading experience. If we click onto the button, we need to trigger a series of network requests. First, we're going to download the form. From the form, we'll need to download the business logic associated with this form, which is in the user service or in the user asynchronous action, or however you want to call it. Right after that, we'll be able to execute the logic associated for saving the user's profile data. Once we save the user profile data, we are going to pass down the component tree what we receive from the server. We're going to have to download from the network the app component and rehydrate it. We're going to do the same for the profile component, as well as for our details components and a certain formatter for the user's name. This could be an Angular pipe, let's say. Once we do that, we can complete this single user interaction handling. And that's not ideal, right? See how many things we had to do and how many resources we had to download from the network only for a single user interaction with our app. And this is a very small toy example. We have a series of waterfall downloads, and that's not ideal. Here is what the user experience is going to be if they were a developer looking from DevTools. That's it. See how we have this waterfall right here? That's pretty bad. In the worst case, we would want to download this at least serially to not mess up with the browser's number of requests they can handle at a certain point. So what we can do is improve the way we serve applications as well. These two techniques we have been using in Google for the past over 6-7 years, I would say. They are also adopted by other big companies such as Netflix. And let us look at how serving of applications with enabled progressive rehydration looks like. Of course, one alternative is to pack our entire component tree into a single JavaScript file called route.js. This way, we have something like progressive rehydration eventually with a single script tag that we're going to download only once the user starts interacting with the web app. We have a single request for getting the route, and we can get it from a CDN, so that's easy, and probably is going to be in a close geolocation to our users. But see, some routes, they grow faster than others. For example, here in Google Search, we have a widget for showing a carousel of videos, we have a calculator, we have NFL scores, we have a weather forecast widget, an alarm, another carousel, and in general, route level code splitting does not scale that well, because some routes are always going to be much bigger than others. What we can do instead, though, is during server-side rendering, return not only the rendered content of the page, the rendered DOM, HTML, but also the dependency graph across our individual modules. From here, once we have to download a certain page and perform an action, we can traverse this graph and figure out which are the individual files that we need to load at a given point, and send a request to our CDN-like server, which contains all the different modules that we need to get, so that the server can assemble them together and return them to our front end. How does this work with a static CDN? It doesn't work at all. For the purpose, we need something more complicated. We need some logic on the server which can handle this concatenation of files, this bundling on demand. Cloudflare recently they released workers which allow us to implement this functionality if we want to. In my opinion, there are a couple of more things which are going to be part of the frameworks of the future, such as data analytics and machine learning. Tools such as Guess.js are going to help us make more data-driven decisions and optimize the user experience per user, not for everyone. Not pushing generic solutions that work for everyone in a mediocre way, but instead publishing personalized solutions that work ideally for a particular user. In this presentation, we focused only on how to make our developers happy, because that's pretty much everyone's desire to follow our business needs so that our users can be satisfied by the experience they have. In the Angular team, however, we're primarily focused on making our developers happy, everyone using Angular, and making sure that we're satisfying all of your needs. So please reach out to us if you see that there is a place for improvement, or if there is a way for us to improve your development experience in general. That's how we can build the framework of the future together. Thank you very much.
Okay, that's it.